Oh my goodness, I've survived to my last video. This is our last video in 5.5. I think I'm just shy of 100 videos that I've created so far for the rest of this semester. So I'm glad to be done, just like you guys are glad to be done. But let's do our last two examples. This is example number 3, C and D from 5.5. This is the idea of combining our U-substitutions and our definite integrals. So do example number 3C with me. It looks like to me this is a chain rule, and so that's probably our clue that we're going to use U-substitution. And so I'm going to call U the 3 minus 5x. That means the derivative then is negative 5 dx. And I don't know about you, but it looks like we're missing that negative 5. So I'm going to plug in a negative 5 as long as I balance it out with a negative 1/5 in the front. I'm then going to use substitute. I have a du on the top over u squared, and I don't know about you, I don't like that du on the top on the numerator, so I moved it off to the side and called it 1 over u squared times du. Don't forget you still have the negative 1/5 in the front. And now it looks like I didn't change my limits to u limits. I kept them as my original x limits. Let's see what happens. I'm going to bring that u squared up to the top and make it u to the negative 2. And then I'm going to use my power rule and integrate. And so if I have u to the negative 2 and I add 1 to the exponent and divide by the new exponent, I get this. I get u to the negative 1 over negative 1. Don't forget you have a times negative 1/5 in the front. And then I have my limits of 1 to 2. Remember, those were x limits, so I can't substitute in yet until I substitute in back my x's. I'm going to simplify a little bit first and bring that u to the negative 1 down to the denominator so he turns into a positive 1. And then I'm going to substitute in my 3 minus 5x. Two negatives here, made a positive, and I brought this down to the bottom so that I have u to the positive 1 in the denominator, and then I back substituted. Now that I have x's, I can plug in my x limits, my 2 and my 1, using my fundamental theorem of calculus. I'm going to simplify, get common denominators, and then get a final answer of 1/14. I hope you got the same thing I did. All right, last example. Here we go. I see, please don't do this. We can't cross off those x's. Don't try to get crazy on me. All right, so it looks like we have a quotient rule. We can't make it look any nicer, and because there is no such thing as quotient rule, this must be a u substitution. So think about what you would call u, think about then what the derivative would be, and think about how those pieces are going to fit together. Pause the video and see how far you get. On this one, I'm going to try u as my natural log of x, that top piece. And I know then that the derivative of natural log of x is really 1 over x dx. And so in my problem, I have the natural log of x, that's my u, and I do have a 1 over x dx as my du. And so I have a u times du. I didn't have to multiply by any sort of constant, and so I have an integral that looks like this. It looks like I have not changed my limits to u limit, so I need to make sure that I remember to back substitute. I can find the antiderivative of u du as u squared over 2. I need to back substitute in what I called u in the first place, which was my natural log of x. I can use my fundamental theorem of calculus by plugging in my upper limit, plugging in my lower limit, and then simplifying. Natural log of e is just 1. 1 squared is 1, so I get a 1/2 in the first term. Natural log of 1 is 0. 0 squared divided by 2 is just 0, so you should get a final answer of 1/2. Try it that way. Maybe try it again and do u limits and see if you get the same answer. You should for both of those. I just decided to keep my x limits, but either way would be the same correct answer. Just make sure you're showing me all your work so I can see what you did. All right. That's our end of calculus for the semester. We've made it through. I know it was difficult. I know it wasn't what any of us planned, but we did it. Let me know if you have any questions going into our last unit exam, and I will see you guys soon.